This is the Insurance Institute for Business and Home Safety's Disaster Discussions podcast, where we explore the intersection of weather and the built environment.
Previously, in part one of Disaster Discussions, a new revolution, how AI is transforming disaster resilience. We trace the sweeping history of artificial intelligence from its roots in science fiction and pop culture to its emergence as a real-world force, reshaping how we live and work. We explore the major technological revolutions, agricultural, industrial, and information, and how AI is poised to become the next game changer. Our discussion covered the evolution of AI from early concepts and landmark moments in pop culture to the rapid rise of generative AI and large language models such as ChatGPT. We also highlighted the ways AI is already moving beyond science fiction, setting the stage for its transformative impact on disaster resilience, weather forecasting, and insurance. Today, in part two, we're diving into the real-world impact of artificial intelligence on disaster resilience. We'll explore how AI is revolutionizing weather forecasting, risk assessment, and insurance, making communities safer and smarter. You'll hear about cutting-edge research at IBHS, the rise of AI agents and behavioral models, and the challenges and risks that come with these powerful new tools. Plus, we'll look ahead to the future of AI, what's on the horizon, what could change next, and how these innovations might reshape the way we prepare for and respond to disasters. So we're continuing this discussion with our guest today, Dr. Hesam Fallahian, Director of AI Research at IBHS. All right, let's continue this awesome discussion. We want to talk about some of your research that you're doing here at IBHS, some of your work. Share more details about just some of the projects that you're working on here.
Yeah, sure. So we, as I said, we have a broad range of projects here, ranging from classical predictive modeling to fine-tuning LLMs and create SLMs, and also designing AI agent for our work. What we're doing right now here at IBHS is just integrating the cutting-edge AI to the physical world resiliency. And I'm in charge for designing the whole AI ecosystem we need to change how we think about risk and how we deal with it. So let's just dive into some of our projects. One project, we have terabytes of data over 15 years. Multimodal data contain imagery, some videos, text, and a lot of stuff that you cannot find anywhere else. So we are fine-tuning our local model here. It's a reasoning model that, let's say, it's a IBHS specialist that can answer any question about the home resiliency and risk management in the area that we are working on. And it's beyond a simple chatbot. It can easily predict the risks and then give you the solution for that. So at the top of that, we are creating some AI agents to understand the people behavior towards the home resiliency and how people behave when they are exposed to some risk like natural disaster. To do so, we are collecting some data. We use our own model, and then now we are evaluating that. In the computer vision part, so we are actually working to design our first vision language model, which is a model that you can talk to our imagery and multimodal data through an interface and get the information. And where we can use it, for example, for the inspection or for early detection let's say we can scan some images from properties and find the more at-risk ones, and then give them some tips and guidance for improving those, for example, at-risk part, to mitigating that risks. In the research team, so we, as I said, we generate a lot of data. For example, if I want to mention one of them, I can take the hailstone measurement. So we have some object detection model, depth estimation, that we can measure the length of hailstone from a camera, the phone taken photos of a hailstone. So which means this just measuring hailstone based on the 2D ugly photos is not perfect photo high resolution. And yes, there are a lot of projects, as I said, but if you have something in mind, I can explain it in detail.
Yeah, well, you gave a presentation on AI on Lunch and Learn a while back, and one of our kind of homework lessons for that is we had some 3D hailstones, and I think you told them to set, did we set them on a table, or was it in different locations? And you had us all take photos on our phones and then upload the photos. And what was it were you trying to pinpoint the size?
Yes, and so because I knew the reference objects that was on those pictures, we did it on purpose because we want to create a training data set. Mm-hmm. This is how AI works, you know. Some use cases, we create some training data, and then we train model on that, and then we can predict on entirely new image. And those images were taken by employees because we want to be natural, because people make mistake in terms of the holding camera in different angles, making some perspective that you cannot easily just by just converting the pixel to inch, find that length. So we collected all of those data and improved our model by that.
Yeah, that was really cool. And another really cool example that comes to mind is, I think it was 2024 out on our hail field study. There was a huge hailstone that fell in Texas, and a storm chaser had collected the hailstone. They took several pictures of it next to different objects. They were kind of, in the weather world at least, they were kind of famous for a short bit there, and that the hailstone was taken next to a Monster Energy drink can. Someone else took a photo of the hailstone next to a pineapple, and then there was a work glove as well. But then they threw the hailstone back. They didn't take it with them, and they didn't save it. And this hailstone was absolutely enormous. We were pretty certain that it was possibly a Texas state record. We sent some of those photos to you, and so you gave us kind of a range of what you pinpointed the size likely to be. Tell me about that a little bit.
Yeah, so that I use exactly the same model I just talked about. So we just took those photos. We had some references on those photos, like that monster can, or one photo was the car plate. Okay. Yeah. So, and based on the model, we generate a minimum maximum because we had a confidence level, because we didn't want to just give them false information. So the minimum size of this hail is that, maximum size is that, and that was a cool project because currently they are just doing that. It's a visual inspection. Mm-hmm. And in the visual inspection, you cannot reproduce the errors. You cannot, because it can be different from a person to another person, a picture to another picture, a camera to another camera.
Right.
And that's not the things that you can rely on, even if in one of those photos, the visual inspection can do better. But it's about the reproducing the way and creating a framework. Then AI can help us to do that. And the most important thing is we can improve. If you create a model building a framework, you can just feed in more and more data and make it stronger. it's exactly like the difference of, for example, in your experience, ChatGPT 3.5 in November 22 with the ChatGPT 5.2 right now. It's the same thing because they almost have same architecture, but they train on more and more data.
I would not have paid $20 for ChatGPT 3.5. I can tell you that. Switching gears a little bit, you told me one time that, so we have a lot of sensors, sometimes dozens of sensors on all of our experiments. You told me that there may come a time, occasionally those sensors fail. You said that AI may be useful in predicting ahead of time when some of those sensors may fail in something like a wind or a fire experiment. How far away are we from that? And tell me a little bit more about that.
Yeah. So generally, AI is about catching the complex patterns in the data set. Like even the LLMs, it cannot understand the words. It's a guessing the next token, next word, next sentence after this based on the trained data. So it caught the pattern and can generate that realistic answer. Same thing here with the different models. We are just because we had a lot of failure examples in our research data. We will train on those data, and then we can proactively predict the failures, or one step back, we can suggest a best experiment design, the AI generated experiment design, to prevent as much as possible to, for example, get to the failure, because we are conducting very expensive research here, and if we can save one of those failures, which means we are saving a lot.
Yeah, exactly. A lot of time and resources. And of course, the data is so valuable. We don't want to lose the data, most importantly. Well, that's super interesting stuff. So changing gears a little bit, I want to talk about how real world applications of AI are being used in the resilience space. So first, weather forecasting and monitoring. Forecasting models are incorporating AI to improve numerical weather prediction, analyzing some of those massive data sets like you talked about, agents choosing the best forecasting model based on current conditions, improving accuracy for hurricanes, tornadoes, and floods. Machine learning is being used in climate modeling to accelerate climate simulations, helping researchers predict long-term trends and extreme events. Severe weather detection, AI is able to identify tornado signatures and flood risks faster than traditional models. And then in the disaster resilience space, it's being used in risk mapping to identify vulnerable areas, building performance analysis to evaluate structural designs against hazard data, to recommend resilience upgrades. You kind of mentioned that a little bit, things like fortified standards. Wildfire mitigation, AI agents monitor vegetation, weather, and satellite imagery to predict wildfire spread and trigger early warnings. And then community preparedness planning as well. In the insurance space, we're seeing AI being used in risk assessment. Those models predicting property risk based on location, construction type, and historical loss data, improving accuracy, speed, and adaptability of CAT models to more accurately predict hazards than traditional physics-based models alone. And there's an example that I wanted to talk about. You said that in this space, we could train a model to do something like generate synthetic claims on hail data based on a geographic location. Tell me about that.
Yeah. So, that's as I said. So during my PhD dissertation was about the synthetic data generation.
And what exactly does that mean?
Okay, so it means that it's like, for example, with generative models, you can generate things from scratch, generate a photo of a person that doesn't exist, generate a deepfake video that is not real. But you cannot, with the human eye, it's really hard to distinct between the real and fake one.
It is.
This is, I did it for the tabular data. So I create during my PhD with the older models. So now, if I want to think of, I can do better. Definitely, with the synthetic data generation, you can create you can generate data synthetically from scratch for the conditions that doesn't exist in your current data set.
Okay.
So, which means in your data set, in our claim data set, we have a number of claims. For example, let's say for the hail claims, we have different types of roof, we have different geographical location, we have different hail impact, and so on and so forth. So we have a data set, but we have a few number of data that we cannot train a reliable model on, because it's not that many that we can get the confidence level we really want. So what I've done, I generate more synthetic claim based on those features, and how it works is very complicated. But I generated more claims that really doesn't exist, but we ended up with the 100,000s of claim for example, the first one was Colorado, if I'm not mistaken. So we ended up with 100,000 of claims. And using those claims, we trained a machine learning model that can predict the loss. For example, in this zip code, with this impact, with this roof, you will end up approximately this loss.
Okay, interesting. I got it.
It's like a CAD model, but it's a deep learning version. It's like a framework. Mm-hmm. It's not a just mathematic formula.
Right. Okay. Interesting. And I want to talk about some other use cases in insurance. Claims automation, speeding up claims by analyzing photos, videos, and policy details for damage verification. Fraud detection, flagging anomalies and claims patterns. Dynamic pricing as well. AI agents continuously updating risk models using real-time weather and property data to adjust premiums dynamically based on evolving risk factors. I think some grocers are doing that to adjust grocery prices in real time. That's a controversial topic there. But how will these advancements in these different categories affect home and business owners over the next 5 years? Our mission is to reduce those losses that we believe are preventable. How are we going to embrace AI and do that even further?
So first of all, so you already mentioned all of the kind of projects and advancements going on in AI in that area. But the only things that I can say is it makes risks more visible to homeowners, to insurer, to the agency that are involved in terms of mitigating risks. So when you have more clear vision about the risks, which means you can prevent the losses that we recently seen in multiple locations in the country for the wildfire, for hurricane, or whatever it is. You can generate more resilient houses based on those data, and you can manage risk better to save lives and changing the gear from what we can do about the tragedy after a disaster to what to do before to not to have that tragedy.
Right. Yeah. I love that idea. And I hope we can actually do that.
Yeah. And I'm really optimistic in the next 5 years. Yeah, we can do that really.
That's awesome. What are some other pros and kind of real world success stories involving AI, especially in some of these spaces we've talked about today?
Yeah, so you already mentioned all of them. So for example, for the hurricane prediction. We can use there are a lot of AI models that at some point can outperform the physical models, but the case is because it's not maybe it's not the main things for predicting these things, but the point is this is a framework that can get better and better over the time, and at some point can really outperform any physical model. For example, for the wildfire, now we are using the satellite imagery data and also the fire trajectory to just predict how fire spread out. For example, you can use it for evacuation alert. You can use for just dedicating the front line, that are exposed to that. And eventually you can save more life.
Wow. That's amazing. So certainly many, many pros. We've got to look at both sides then. We've got to talk about some weaknesses and risks as well. One being, a lot of talk about the negative environmental impact that AI could cause. A study that was published by the Amsterdam Institute for Environmental Studies estimates that the energy used by AI systems globally is on the same order of magnitude as the average electricity consumption of the United Kingdom. The carbon footprint, that same study shows AI could end up with a climate footprint comparable to a major world city, such as New York City. And then water usage, the study estimates that the amount of water used is on the same order of magnitude as all bottled water consumed worldwide in a single year. Also concerns about e-waste and hardware demand, accelerating demand for specialized chips that leads to increased mining for rare earth metals and electronic waste from outdated hardware. So you say the current administration's policy is for AI dominance, which focuses on accelerating infrastructure rather than restricting impact. So knowing this, what emerging strategies and technologies are being deployed this year to mitigate or significantly decrease this environmental footprint that we've talked about, but while also allowing it to rapidly accelerate?
Yeah, that's correct. So there is no single federal law for example, mitigating these risks about the environmental risks. But there is a piece of legislation recently proposed for monitoring water and energy consumption and also air pollution for the data center. Data center need to report every quarterly or something like that. So that helps us to understand how they hurt the environment, and then we can take a plan. But now, because we don't have any thing, Europe has a AI Act that can mandate data centers to do some of this work, but we don't. But the company can go towards something called green AI. For the green AI, we have a couple of things we can do to reduce those effects, like the knowledge distillation, which means train the smaller model because the current model that you are using in day-to-day work, that they are general model. They can answer question about anything. But we have another concept that have a lot of model in-house called SLM, a small language model. They are specialized and trained on a specific task, and they can do that task better than the large language model. Whenever you don't need broad knowledge, it's better to create a smaller language model for your AI agent. Another one would be the carbon aware scheduling, which means using renewable energy for the peak training time, or for the cooling, you can use the immersion cooling. It's a kind of new way of cooling that you can reduce the water consumption and also the energy. And also the last things would be using the high efficiency processing unit like TPU that Google recently is using that, which means they can process more data efficiently in lower time with the so eventually lower energy that can reduce those effects.
So it sounds like it's being left up to the individual companies to decide how they want to do that for the most part.
Right now, yes.
Okay. Interesting. What is the biggest misconception about AI in your opinion?
I think people think it understands the world, but it doesn't. It doesn't understand the world. It doesn't know about common sense. It's built at the top of corpus of, for example, let's say for us would be the IBHS document or whatever it is in their training data. And then they are guessing the next word. You ask a question, it's predicting what would be the next word over there. So I think this is the biggest misconception about AI.
Do you think AI can be biased?
Yes, because it's trained on our data. So we all have some sort of bias in our, for example, mind, and we can transfer those to LLMs, and that one can be amplified later, and you will end up with bias. So we need to be careful about the training data.
Yeah, so you say AI, it doesn't understand the world. So what happens if you trust AI too much?
You stop questioning it. You know, you are not, whatever it says, you accept, because it can give you misinformation confidently.
Yeah, absolutely.
Because it cannot understand it. There is no sense of truth in AI. So you should use AI, but not blindly trust that. You need some oversight, need some, research about the way. Just be careful.
Yeah. I was asking a pretty simple question about just a basic mathematical formula. I could have done it myself with a calculator, but I just kind of wanted to find out what AI would say. I wanted to divide some payments with a certain interest rate. It gave me this wacky number. It was either exorbitantly high or small, but it was a fairly straightforward math problem, and it was just completely wrong. Like, how is it completely wrong about, basic things like that, yes. Even a math formula?
Yeah. So this is two different components. One, the way that you prompt in, your prompt, it was the way that based on the training data, that was the best answer the model can generate. And the second thing is about the model ability itself that I said. For example, there are a lot of mathematical small language model open source that you can use that can answer very complex mathematic questions. But you need to use them for those tasks. But
okay.
that doesn't mean you cannot use, for example, ChatGPT. No, but it depends on the data, garbage in, garbage out.
Mm-hmm. It's not that model's specialty.
No, yeah. So it was there, as I said. For example, if you give me the same question you ask, I may ask in a way that get the right answer.
Okay.
Yeah. So if one is prompt engineering, one is the model ability to predict, to guess your answer, because it cannot understand the logic behind those math.
Okay. Interesting. What is the hidden cost of smart systems?
I think it's the scaling the errors, because you train model on the piece of data, and that data may have a small error in that, but millions of users will use model to generate some responses that can get the wrong answer from it. So I say the scale is the most dangerous things.
Yeah, you say a single flaw can affect millions of decisions.
That's right.
So that's something to keep in mind. A common word that's been heard a lot this year, a hallucination. What is a hallucination? How does that happen?
Yeah, the hallucination is when AI give you a wrong answer confidently in the way that is hard for you to identify. And it has a couple of reasons. One of which is, for example, your question is beyond that model knowledge. It wasn't enough data in that training data set to be able to catch the pattern and predict the right answer for you. But there are a couple of other reasons.
Yeah, here's another question I think a lot of us want to know. Why does AI constantly compliment me? The first time it complimented me, I was so taken aback. I was just so surprised. Sometimes I ask intentionally dumb questions that are not good, and it still compliments me.
Yeah, because so they are designed and engineered to satisfy you and flatter you. It's about the way they are designed, and then when you are asking some things that it's a kind of hallucination, it's not the part of training data set. A good convincing would be polite, encouraging you. The encouraging you would be a polite answer to the question that there is not in the training data set. So that you start asking questions, you say, "Oh, that's a great idea." You just start expanding that maybe false idea, and it continue just confirming your what you say and encouraging you to continue.
So that sounds like that is by human design, the fact that it flatters you?
Yes, some sort of yes. For example, there are some safety design behind these chatbots, because the chatbots is not all about the large language model, the model behind that they are powered. They, for example, when you're using Gemini or ChatGPT, if you there is an option called the data usage that use your personal data to use those piece of data in the next, for example, chat you have with it. So they are engineered to go beyond that just guessing game, to give you more natural responses and also the things you like to hear.
Yeah. It comes across as just such a sales tactic, right? Like if I'm in a store trying on an outfit and the salesperson says, "Oh, that dress looks great on you," right? Yeah, sure. I'm more inclined to buy it now that I know it looks good on me. Yeah, it's like that's what I feel like when I'm talking to ChatGPT sometimes.
Yeah, exactly. And for example, if you say something inappropriate to ChatGPT, they never respond back. So that's not in the real world, right?
Right.
You say something,
you insult it.
Yeah. So this is the way engineered.
Okay, that's interesting. So that brings me to an article you published on LinkedIn. It was called "The AI Spiral: Why Chatbots Get Stuck and How Their Architecture is to Blame." In the article, you talk about the delusional feedback loops or the conversational spiral. Tell me about this article.
Yeah, that article was about the chatbot memory. So I used that podcast to talk about this stuff. I used that podcast to talk about this problem. So, and that was the case. Imagine when you are initiating a chat in ChatGPT, it's like a chalkboard. You just fill up the chalkboard, and you have a limited space to store those information. When you get into a very long discussion that's more than that chalkboard, it will start erase the fact from the beginning and replace what you said in your chat. So, and that causes it will forget what you said before and start getting in the loop that can just give you an answer based on your conversation without the facts you already provided before. So and now it's getting better and better, because that was for 2 years ago, 1 year ago, I don't know. But now we have the models with a larger context, with the bigger chalkboard that we can store more data. But you need to be aware there is a risk on that part.
And you said you should actually not save your chat history. You should start with a new chalkboard, basically.
I'm not a fan of saving chat history. There are some pros and cons for that. For example, I turned it off because sometimes you start asking some question that are not real. You say, so imagine I'm a doctor, I'm a physician, I do this, so what's your suggestion? It catch some fact about you and store it in a place and then use it for you. You are not a physician, but it may, just get that point and store it somewhere and then treat you as a physician. So that's the cons, and the pros is so it can understand your behavior. For example, even for when you are searching for something, actually, when you, for example, if you use Gemini a lot, so when you search for a product or search for a sentence, you will get exactly what you wanted to see on the screen, because it has your previous chat history, can just look up over that, extract some facts, and based on fact, just return some answer to you.
Okay. So it can't tell fact versus fiction when you are giving it information about yourself.
Yeah, it's hard because it depends on the way that you describe. If you say, I'm not a physician, imagine I'm a physician, so that would be another case to say, I'm a physician and blah, blah, blah. So that's the part and you cannot control that, because this is a natural way that people talking. So I prefer just to turn that off.
Okay. Interesting. Well, we keep hearing, these bizarre stories in the media about people who feel that they've made a new friend with one of these chatbots. Another quote from line from your article, you say, quote, "A chatbot is not a friend or a coworker. It is an assistant. These systems are made to be nice and flattering, which can make people feel like they have a real connection and authority. It fills in linguistic patterns, a guessing game of next token prediction. It doesn't check for truth or understand it like a human would." We talked a little bit about this, but you keep hearing these strange stories about people, falling in love with their chatbot.
Yeah.
A little weird.
Yeah, unfortunately, but it's happening. So first of all, this is a tool. It cannot understand you. It doesn't have any memory of you in the real world. It doesn't have any sense of truth. There is no common sense for that. And just it's a guessing game. You need to repeat that out loud for yourself to say, this is not my friend. This is not my family. There is no emotional connection with that. There is no relationship. You just use it to just improve your performance on the job you're doing, on even your personal life. You're doing something at home, you can use AI to make it easier. Use that, but do not trust it. And also, you don't treat them as you're talking to a human, like some science fictions.
Well, in your opinion, what is the most dangerous way AI can be misused?
feeding, as I said, just feeding misinformation, amplifying those misinformation in a convincing way. Mm-hmm. That was dangerous, because never you heard, for example, when they are giving you a piece of information confidently, you probably believe it.
Right.
And if you don't search somewhere else or research for that, that would be problematic. I think that's the case.
And we're getting close to the end of our podcast here, but I do want to ask about the deep fakes. One really interesting example was when Hurricane Melissa made landfall in Jamaica earlier this year. There were quite a few videos that were AI videos. They looked incredibly realistic. It was just buildings, being damaged by the storm. One in particular that I can kind of picture in my head was shared, I don't know how, thousands and thousands of times. It might have even been a couple 100,000 times. Where are we with this deep fake situation? We're seeing deep fakes of people. That's very, very scary and sounds very dangerous to me.
Yeah, and you can see a lot in politics, So yes, and the bad news is it's getting better and better, more realistic. So they are working on some algorithm to detect these deepfakes, but this is you cannot just use them everywhere, and you cannot expect ordinary people on the street to not believe and fact check every piece of information so I think the best way is to educate people, not to believe anything you see. Mm-hmm. It's no longer the case. Maybe you will have same problem in courts. They may just dismiss any evidence based on some, for example, recorded video, because they cannot catch the things. Who knows? But as I said, there are some topics like ethical AI, explainable AI, and these kind of stuff are helping to generate some guardrail for the AI to mitigate those risks, but you cannot get rid of them.
All right. Well, I want to talk about what's ahead and hopefully some more positive things. Tell me about your big vision behind your work this year. What would you like to solve?
So actually, we started new projects about how we can help people because we have some program here like Fortified and Wildfire that can improve your home resiliency, and you will end up with less risk, less loss, and there is a lot of good things, but people don't always adopt them, and they know it's good. It's good for their peace of mind, but they hesitate to take action and do that. So we are studying their behavior, the homeowners' behavior towards natural disaster and home resiliency, to create a framework to send them a message at the right time, mm-hmm. the right place, and also detect at-risk one, to be able to push them to adopt these programs. And that contains a lot of AI and deep learning algorithm for understanding the people behavior, to understanding the risks, to generating those messages, to create a strategic playbooks, to give it to the one that want to just promote it to someone else. And this is the main projects that we are working on this year.
And you mentioned this earlier in the podcast, but we want this when we change the way we think about risk, we want it to be something that we reduce ahead of time instead of after the disaster has happened.
Yeah, that's correct. So,
and we talked a little bit about computer vision. How does teaching machines to see help with some of these resilience measures?
Yeah, so we can see things and assess risks at a scale and speed that human never could. Mm-hmm. So we have terabytes of multimodal imagery data, and we are training our model to see the things that it's about the resiliency, it's about the risks at home, and that would be specialized in that domain. So, and we will end up with a very strong model, actually, and we can, for example, visually inspect. The machine learning model can visually inspect the home and say the risks, the way that you can mitigate them.
So, Hesam, if there's one thing you want people to take away, or a few things, kind of give us your final thoughts for this episode.
Yeah, so I have already told that in disaster resilience, the technology gave us the chance to just move from reacting after tragedy to preventing it in the first place. So I think we can, using AI and with the project that we are working on, I think we can help to achieve that goal.
All right. Well, this has been super, super interesting. I'm glad that I got to sit down and talk all about AI with you. Hesam, thanks for joining us on this episode. And this has been Disaster Discussions, a New Revolution, How AI is Transforming Disaster Resilience, Part 2. Thanks for joining us.
Thanks for listening to the Disaster Discussions podcast. Join us next month for a new episode. For more on IBHS's ongoing research efforts, visit ibhs.org.